Hey guys, I welcome you to the day 5, which is 12th of June, um, 2024. Today is Deep Work session 1, where I am gonna try to find out if there are any LM models which is good for data analysis and can I run it locally. That's the agenda today, right? So let me recap what we did till yesterday. So till yesterday we actually were able to download LLM locally and run it. So the way we did it is basically we actually uh, downloaded Olama, and Olama is a pretty good website from where you can actually download LLMs and run them locally. Then we used Open Web UI, which is like an interface that connects with the LLM that you have in your machine, and using that you can interface. So we also did that yesterday. Now, so before we go to the agenda, I just want to complete this video from Chuck where he talks about how we can also use stable diffusion, because I'm really interested in this aspect. So right now it's 4 p.m. So I just want to spend at least, even if take I just want to spend 10 minutes on this, but I know it'll be more than that because I am having some issue installing this particular part of the code. I tried it in the morning, but for some reason it's not working. I'm gonna try to debug that, try to understand what's happening wrong, and yeah, then that's the agenda for today. Cool. Let's get to this then. Let's start. Okay, so I'm gonna go over my PowerShell window, which you can't see. I know I want you guys to see it, but for some reason you won't be able to. Uh, yeah, but I'm gonna just continue anyway.
.bash rc to
Okay, so this is the problem. Hmm. Hmm. It appears that Vignesh is not listed the in the file environment. This could be the reason. Recognize. Yeah, I move Ubuntu from C drive to D drive, and that's reason is not good. Good. Do you know a way how I can link it? The reason also for context, I am able also for context I'm able to see the file structure on my machine using universal dollar command, and there I see that uh, home slash English folder, and I also see root, and both of these file structure have dot bash rc in them. Mhm. It sounds like user configuration was not transferred correctly during the move. Let's link the home directory properly to ensure that the user is correctly set up. So what I'm asked to do here is back up my current state, okay, create the user and set the home directory, check for user info, set default as current home directory, verify bash, ensure bash is source as bash, come on. Okay, let's try this out, but I hope nothing breaks. Cool, so let's do that. Mm, 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 Sudo not found. I'll ask the doubts here because I don't want to disturb it. Okay, I can do this, right? I can ask another. I recently transferred Ubuntu from C drive to D drive, and when I try to run a sudo, I'm getting an error saying that sudo is mm, yeah. Open each file and look for lines that modify the path variable. Okay, okay, so I think the issue here is that um, in the drive I do not have Ubuntu files as using below commands. I move Ubuntu from C drive to D drive, and now the issue the issue is when I check for PWD, I get folders and files in my D drive, and that is what is set as path. Okay, but I also see that when I check for dollar dollar I have home slash Vignesh, where all the necessary files are present. I think we just need to link them and problem will be solved. Also, currently we have the path issue, which is what would be the right steps to to resolve the overall problem. Okay, great. Now this seems like a logical steps. Okay, so I'm opening a new path environment right now. Okay, I'll just open a new path PowerShell, sorry, PowerShell, and then here what I'll do is WSL. I'm just gonna copy this code and come here. Okay, so Verify that Ubuntu is listed and running. Oh, it's not running. Okay. Okay. Why? Okay. Correct the path environment. Okay. I checked for. I checked. I checked the first command, which is this, and this was the result. Okay. Here are the steps to get WSL instance running. Check the path issue and ensure sudo is installed and working. Start the WSL instance. Start your Ubuntu from shell. Verify the path environment. Will appears multiple times. You need to clean up a function as previously mentioned. Okay, fine. So let's open this and we'll do this. Okay. Okay. Check profile in your home directories. Copy. I think I'll copy one by one. Look for any lines that modify the path. Remove the command or the redundant lines to avoid multiple path entries. Okay. So I'm just checking now nano and I'm checking for export path. Okay. So shop item prompt color term if alias. So basically I don't have anything as path in my bash file, so I just close this. Control X. Okay, so I just close this one. Control X. Okay, I've closed this one. Now let me just open this one. I don't have anything here as well. Okay. Okay. I checked. I checked path and this was the output. And then I checked system do not have do not have path variable. This might be coming from given that path includes your main device specifically. To resolve the path issue and ensure the Ubuntu setup credit, let's do the following. Check the global variable. The path must be the path must be set in global configuration files. Check for path settings. Okay, so let me just do this. Look for any lines that lines are setting or modifying the path variable. Oh wow! Yes. I opened and saw that opened the below. I think this is I think this is what to say. I think this is um modifying the path. Incorrectly. So we should not cause possibility to be listed 3 times. The extra 3 times you saw earlier might be added by the configuration files. Okay. Oh, is it? Back up the edit. Okay. Just the path. Bro, this is asking me to take what? This is asking me to do something that I don't know, which kind of scares me. Check if the other files are modifying the path. Yeah, before we do anything here, because everything seems to be the same, right? See, user, local, bin, this. Why should I change this? No. Yeah, this is. Like, why would I change this? I don't want to change this. Let's try this. Hmm. Hmm. I think let me restart my machine. Okay, let me restart it, and then probably if we are not able to pick up here, then we'll come back to ChatGPT. Cool. So I'll just stop my recording, and then I'll just restart my machine and see if there is still the issue persist with Ubuntu not able to source the um, home file with the bash src as it says. If it does not, then again let me try at it again. Okay, so cool guys, I've restarted my machine, and I'm gonna open PowerShell and see if this works. So I'm just gonna do that. PowerShell. Right, PowerShell, and then let's bring it up here. Right. So first and foremost, let me just list it and see which one is working. And I'm also gonna open my OpenAI and check for the ones which there was a command which actually uh, showed us which WSL work, but right now, since I am restarted it, I don't think it should matter. Mhm. Mm. Wow. Okay, this is the one. Everything is stopped. Okay. There is star before. What does that symbolize? Okay, okay, cool. Doesn't matter. Okay. So WSL dash D dash 2 dash. Okay. So ls interesting cd snap into docs. I have no idea where this is going. Crazy. So what's happening is I went to my home directory and I okay. No, do. Probably. Let's see how this works. Echo path. Echo underscore root is the home. Okay. C home. Okay, so let me just try this command.
Love it?
and see if it works, because that's the one which is holding us back. Right. Cannot proceed with installation. Kindly remove the root PNV directory first. Okay, I think it is installed. Does it mean that PyEnv is already installed? Okay, nice. Let me just start with that. PNV not found. Mm,
Run that -rc files. So we can actually use the pyenv command. I'll just copy this, paste it,
I should have saved that command. I will type it out. Okay. Come on, guys. I'm gonna delete this. Should delete. Okay. Cool. So we'll just go with the. I've deleted the pine file. So let me just go and run it again. Right. Hash. Perfect. Perfect. Great. So this is the command that I wanted, that I got, and
then right here,
this is what I want.
it tells us we need to add all this or just run this command to put this in our bash rc file so we can actually use the pyenv command. I'll just copy this, paste
This is
it,
where the problem is. Let's see.
then we'll type in source.bashrc to refresh our terminal.
Okay. So let's see what these variables mean in my machine, right? Echo underscore home. This is like root directory for me. Oh yeah, this will work. Pyenv root. Let's check that. Dollar pyenv root. There's nothing coming up. Damn it, bro. Oh, sorry, echo I have to put, no? Echo. Nothing is there. Shit. Pyenv root is there's nothing. Path. Crazy shit is happening here. I have no idea what I'm doing. Okay. So I've done that. Let me put source dot bash rc. Oh shit, bro. Yo. I do have, man. Current working directory is home. Then why pwd home cd mesh plus cd mesh yay. So right now I did not get the command. I think I figured it out.
Now let's see if pyenv works. Pyenv, we'll do a -h to see if it's up and running. Perfect. Now,
Okay. Pyenv -h. Yay, it's working, guys. Awesome, super, great. Cool. Perfect.
Now let's make sure we have a version of Python installed that will work for most of our stuff. We'll do pyenv install 3.10. This will of course install
pyenv install 3.10. Great.
install Python 3.10, the latest version. Excellent. Python 3.10 is installed. We'll make it our global Python by typing in pyenv global 3.10. Perfect. And now we're going to install automatic 1111. The first thing we'll do is make a new directory. mkdir for make directory. We'll call it stable diff. And then we'll jump in there, cd stable diff. And then we'll use this wget command to wget this bash script. We'll type in ls to make sure it's there. There it is. Let's go ahead and make that sucker executable by typing in chmod.
Cool. Just wait for a couple of seconds. And my Python is installing, guys. Yes. Perfect. I'm also thinking of actually working on a content generator, like a content generator, not content generator, but a tool that actually can, you know, uh, generate content for my blog post that I'm planning to roll out. Yeah, that would be really interesting. Perfect. So this is installed. So I will do pyenv global 3.10. Okay. Perfect. Make directory stable diff, then cd stable diff. Perfect. Then I will write this command, which is installing stable diff. Perfect. Okay. So let's do ls. Yeah, I have that file. Great. So I'm just changing its. Perfect. I think now I have to run it.
We'll do it. We can run it. /webui.sh. Ready, set, go. This is going to do a lot of stuff. It's going to install everything you need for open. Set, go.
Okay. Dash web UI dot sh. Okay, I'm getting a. Okay. So it says that this command should be launched as a root. problem is this guy will not work because yeah. Oh my god. Install script for solution to ZBA, tested on Debian 1. Okay, I think I should do the same things. So su ls make dir mm, 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 mkdir dir stable vision उसके बाद I will do this उसके बाद I will do this perfect उसके बाद I will do this come on must not be launched as root. Oh, okay, must not be launched as root. Oh, I didn't read the I'm so sorry guys, I did not read this one. Not launched. Oh wow. Hey, come on. Authentication failure. Oh my god. Okay, I don't know. Shall- Mm, okay, cool. So CD. Mm, Hmm. Facing a couple of errors here.
This is going to do a lot of stuff. It's going to install everything you need for OpenWeb UI. It's going to install PyTorch and download Stable Diffusion. It's awesome. Again, a little coffee break. Okay, that took a minute, a long time. I hope you got plenty of coffee. Now, it might not seem.
The error message indicates that the script is unable to create and activate a Python virtual environment because the what is not available. The model is required creating to resolve the issue. You can install package which provides. Okay, I'll do this. Hmm. Okay. Let's do this. Mm-hmm. Still same error. Okay. Okay. This is a file. So GitHub file, right? Mm,
Frame the video index.
not working
And
for
like it's
me.
ready. Okay, awesome. UI. Let's go. Gonna install PyTorch and download Stable Diffusion.
I've had this launching PyY is not something which really happened to me. It still I'm stuck at this step.
It's executable. We'll do a +X and then webui.sh. Now it's executable. Now we can run it. /webui.sh. Ready, set, go. This is going to do a lot of stuff. It's going to install everything you need for OpenWebUI. It's going to install PyTorch and download
Mm, mm,
Stable Diffusion. It's awesome. Like, again, a little coffee break.
it's not working for me.
Okay, that took a minute, a long time. I hope you got plenty of coffee. Now, it might not seem like it's ready, but it actually is running. And you'll see the URL pop up like around here. It's kind of messed up. But it's running on port 7860. Let's try it out. And this is this is fun. Oh my gosh. So localhost 7860. What you're seeing here is
Just the last step. Just the last step. Is there an existing issue for this? Can't open the file. Steps to reproduce. Steps to git pull. Mm. Path is set wrong now. My installation is not in the directory that I'm looking. I have changed, and that caused this commit where the problem happens. Let's read it patiently. Let's read this clearly. Is there any existing issue for this? I have searched dit. Okay, but where is the GitHub issue, man? State distribution. So the thing that I'm pulling, automatic stable diffusion of UI. Um, um, okay. Interesting. Oh, this is the one. So I should have launch.py, right? File. So launch py. See, this is the file. Oh wow. I should just download this file then, I guess. Can I do that? And then keep this file in my uh, uh, this thing, and it should work. Yeah, because that's how it will work. So I am here. Yeah, so let me just do this thing. Home Vignesh, stable diff. Oh cool, I just will keep this file here and see how things goes. Cut, paste. So that issue got resolved of uh, file not found because I just went to GitHub and did that. I went to GitHub, download the launch file, and kept it here. I just have to now one by one download all the modules. So I think I should check automatic one installation somebody else. Yeah. One year ago.
Xiaomi 14CV with Leica professional cameras. Make it cinematic.
Do you want to end up being third or a second? Or would you rather be a top DevOps professional?
Hello friends, in this video, and this is automatic. And here you can see automatic installation on Windows. So load that one. It's a box. Let on the
Well, I
if you
can do it like this, right? Then
we install, we're going to drag fairly fast depending on your internet connection. For me, it took about 5 seconds. And files we add, we're going to do necessary the window when you could I will use a highest rated of, for example, however, I will use Xformers and auto launch. I will deliberate model, put them inside your base model it was trained on. These are fairly big. As you can see here, this is 1.99 model. It was trained in models related and start the Fusion. It will download some files and some top file. It will automatically launch as soon as this here. Stable Diffusion add thing quickly this folder. Now open Notepad again and drag your web UI user file there. You can, if you want, add git pull here. Now that will try to update your automatic 11.11 every time you start it. However, since sometimes the new updates can break things, I don't recommend updating all the time. The link will be in the CSS styles available here. And good prompts. Some of the popular extension for in and out of your.
Awesome. So I tried a lot of things here to run, but for some reason I'm not able to, and I just saw that you can launch automatic. You can launch Stable Diffusion via some other method. So I'll just try that out and have a Stable Diffusion in my machine, and let's see how that works. I think that will be really interesting to see Stable Diffusion working locally on my machine. So that is pretty good stuff.
Did you know 84% of companies are already using the power of containers in the product?
And there's Stable Diffusion inside OpenWebUI. So it's just right here. Back at OpenWebUI, if we go down to our little settings here and go to settings, you'll see an option for HTTP:// 70 option over here to make sure it works. And actually, no, it didn't. And here's why. There's one more thing you gotta know. Here we have OpenWebUI running in our terminal. If I hit Control-C, it's gonna stop it from running. In order to make it work with OpenWebUI, we gotta use 2 switches to make it work. So let's go ahead and run our script one more time. OpenWebUI, or UI. Once we see the URL come up. Okay, cool, it's running. We can go back over here and say, why don't you try that again, buddy? Perfect. And then over here we have image generation experimental. They're still trying it out. We'll say on, and we'll say save. Llama 2. I'll say this is for a stable diffusion prompt. A bit wordy for my taste, but then notice we have a new icon. This is so neat. Boom, an image icon. And all we have to do is click on that to generate an image based on that prompt. I clicked on it, it's doing it, and there it is. I love this, it's so fun. Now this video is getting way too long, but there are still 2 more things I want to show you here in document. I'll add that one with code gem and say give me. What just happened? Second thing I want to show you. Last thing. I am a huge about it, but I plan to. But
I'll not be able to use stable diffusion on OpenWeb API, but I can definitely use it separately. So that itself is pretty interesting, right? And which will be running locally in my machine. So that is pretty good stuff. Pretty good stuff. Cool. So I just close this for now, and then close this as well. Close this as well. Close this as well, and kind of take a break for some time, guys. It's been like 1.5 hours that I'm sitting here and trying to work this out. So I'm just gonna take a short break. Cool, guys. I took a break of more than an hour. I should have not. So I just went on my YouTube on my phone and started watching these, which is not good, by the way. Yeah, I should have not done that. But anyway, I took a 1 hour. I got sidetracked for an hour, but now I'm back. Okay, so let's now analyze if there are any models that can be used basically for data analysis, right? That's what we're gonna do. Cool. Let's close some of the
what you are interested in.
ports here. Some of the tabs here.
Hey there, this is Kamal, and
This is important. Yep, this is important.
Did I ever do the wrong?
Interesting, they have Discord, right? Let's open Discord and see what the interesting thing we have here. Let's see. Oh, that's it. Announcements. It is loading a 15 GB model. Use 4 to 6 of VRAM. Pretty active, guys. This is today. They were discussing today all these things. Hey guys, is there a model in Olama that is good at data? And this is I want to upload CSV file, and the LLM should be able to give me insights and plot graphs. If let's say interesting. Pat is pretty active on Olama, it seems. What are they talking about? Crazy. These guys are talking. There is so much going on. Wow. Okay. Cool. Yeah. That would be the best thing, that if there is a model film for data analysis. An AI agent is a system consisting of planning capabilities, memories, and tools to perform tasks requested by a user. For complex tasks such as data analytics or interacting with complex systems, your application may depend on collaboration among different type of agents. For more context, see introduction to relevant agents, building a person application. Sure. If I have to create a data analytics, um, then I have to create multiple agents that interact with each other. Okay. The Let me just open this. Are they free? section explains two main type of LLM agents and how they work: data agents and API or execution agents. I also present an agent swarm use case which involves multiple agents collaborating to solve a problem. Note that these agent types somewhat represent the end of a spectrum. Blended purpose build agents can be created for a specific use case. Data agents. Data agents are typically designed for an extractive goal. In other words, data agents assist users in extracting information from a wide range of data sources. They help with assistive reasoning tasks. For example, financial analysts might ask, in how many quarters of this year did the company have a positive cash flow? This type of question requires reasoning, search, and planning capabilities. API or execution agents are designed for an execution goal. These agents can carry out a set of tasks requested by user. Consider the same financial analyst working on an Excel spreadsheet that contains the past year. The analyst want to organize these closing price to one of the most basic formulas. Excel APIs needs to be chained together to perform this task. Agent swarms involves multiple data agents and multiple API agents collaborating in decentralized manner to solve a complex problem. Agent swarms are designed for workflow that include both extractive and execution tasks that require different forms of planning in the agent core. For example, imagine that that the financial analyst who wants to study the top 5 food stocks for investment planning. The sequence of action needed to reach this goal are outlined below. Mine stock prices. Data agents have structured data. Mine stock price. Data agent create structured database. Extract more information. Execute search engine calls to get forum using data agents. Extract information using data agents. Store the information in Excel. Extract user sentiment from social media content. Execute social media API. Using data mining. Data agent perform sentiment analysis using RAG. Use pre-selected metric to generate indicators using API. Generate the report using API engine. Upload key graphs plots to PowerPoint slide. Building a data analysis agents. As more type of LLM agents are modeled, they can interact with each other in the agent swarm to effectively solve the problems. Constraining the problem into different agent verticals enable building agents with smaller models. This requires less effort and customization and maintains modularity, which in turn provides benefit for adding new features, selecting the features you want, and simplifying deployment scaling. In this ecosystem, every agent looks at another agent like a tool and uses its help when required. Building a data analyst agent with this general taxonomy as a foundation. This section dives into building the data agent for a use case of talking to an SQL database for inventory management. The following discussion assumes you have read build your first LLM application or otherwise familiar with basic LLMs. Choose an LLM. Begin with identifying LLM to use. This example uses it accelerates the various models and makes them available as API. The first API call per model if you are working with a model that isn't tuned to handle agent workflows, you can reformulate the prompt below as a series of multiple choice question. This should work as most of the models are instruction tuned to handle MCQs. Select a use case. The next select a use case. The use case can for this post is talking to an SQL database for inventory management. Then populate the database with, for example, 3 tables. Information presented below is for exemplary purpose only and is not intended to convey actual details. Supplier data, product data, inventory data. For an experimentation, store SQLite database Tools, memory module, planning module, agent core. Trying to put everything together, the prompt for the agent core LM looks something like this. Always use memory to help select the tools to be used. Generate final answer, use if answers to user question can vary. The preceding prompt includes all the tools and related information. You can design the course code, harness in a way such that given any tool but the generate the final answer Fox tool, the agent will append the results of the tool used in the memory and situation. It is an iterative greedy approach. If tool, if tool. In summary, the data agent has access to planning capabilities, memory, multiple data access tools, and means of performing related analytic tasks. Figure 3 shows generic architecture. Usage, agent code planning, RAG, then SQL calculator, this, and social structured data. This section provides an example that showcases how different tools can be used together to solve business questions. The key advantage for using an agent in a scenario like this is that the user doesn't need to know details about the database or the technical skills to run queries. How much excess inventory do I have for Google Pixel 6? Based on the table information from the invoice system, you currently have 80 units of excess inventory for Google Pixels. This calculation is derived from subtracting the minimal required quantity from the current quantity in stocks. Query DB tool, need SQL, query DB, store resource in memory, solve math problem using LM, store this final answer generation. The following prompt is for the agent core LM after SQL is generated. Hmm. Okay, there's so much information here, and I would definitely require a summary of everything that's been talked about here, talked in here. Inclusion in paper, we introduce element-based multi-agent model design for automate various types of qualitative analysis, including thematic analysis, content analysis, analysis around theory. Non-flexibility is clear as it can understand various input, including written document, interview transcript, web prompts, and PDF files that we upload. The comprehensive coverage not only acts like data analysis but all broadens its application, making it a valuable model for research working with various quantitative data sources. Our proposed model significantly expedites process while enhancing scalability and accuracy in SC. Furthermore, we conducted an extensive evaluation of the proposed model involving practitioners from different backgrounds. Our research entailed a rigorous assessment with 10 professionals, each representing any professional field. The finding revealed a notable level of satisfaction, with 87% contentment with the model performance. The positive response underscores the effectiveness of a model in meeting the diverse needs of a practitioner across various domains. However, despite these encouraging results, we acknowledge the importance of ongoing refinement to address potential areas of improvement. Our future goal is to focus on exploring the model performance in multilingual settings to extend applicability in diverse global research contexts. Additionally, we will continue to emphasize the importance of maintaining a feedback loop with domain exposed to ensure the ongoing refinement and enhancement of the model's capability. Interesting. Okay. Interesting. Oh wow. Is it open source? Super interesting. Fine. Let's see. It's open source. Nice. Cool, guys. My willpower is very low right now. But I'm gonna push myself. I'll take another break and then push again. I don't want to work right now. I don't want to do anything right now. I just want to chill. Come on. Why is that happening? Probably because I'm not going and having any physical exercise in the morning. Yeah. If I have some form of physical exercise in the morning, then you'll feel good about starting your day. Right? Not having any physical exercise doesn't feel good. You feel drained. I feel drained out for some matter. I don't want to do this one, this task. That enthusiasm is not there. Why? I'm not sure. I should have that enthusiasm. Come on, let's do it. I'll take a break. Come back. Oh, hey guys. So there was a power cut here, and I'm back. And I was listening to this book, audiobook of this particular book called Mastering Money, and there are three authors for this particular book, right? I think one is James Allen, another one is Napoleon Hill, and the third one is Roger Fritz. You can also check this out. And I was in chapter 2 of this particular book, and they said that you need to have discipline. I was not feeling very good, like in the last session, deep work session, and I was not able to focus for a long time, right? And here they said just only one thing. They mentioned that if you have discipline, everything in life becomes easier. And then that one thought made that feeling of discomfort go away, because it's like that, like I have to be disciplined. That's the truth. If I have to achieve this goal of mine, I have to be disciplined. That's it. There is no feeling of discomfort. So my mantra is that just sit, just do it. Don't think, oh, I'm getting this discomfort. Don't feel about it. Just sit. That's my mantra. Just sit in peace and just keep on doing the task, keep on exploring, and whatever ideas you have, just keep on writing it down. That's my goal. So I think we landed here, and I would love to read this one and see how this works. And also there is a video, so let's watch that and figure out if that's helpful. So there's no audio to it, it seems. So what is this? This is LM. List of automatic generated action goals. Oh, interesting. Wow. Hmm. We visualize goals and generate visualization specifications in this work. We pose visualization generation as a multi-stage generation problem and argue that well-orchestrated pipeline based on line language model and image generation are suitable for addressing this task. We present LiDAR, a novel tool for generating grammar agnostic visualization and infographics. LiDAR comprises of four modules: a summarizer that converts data into a rich but compact natural language summary, a goal explorer that enumeration goals given, a wish generator that generates, define, executes, and filters visualization code, and an infographic model that yields data faithfully style graphics. LiDAR provides a Python API and hybrid user interface for interactive chart infographics. Interesting. LiDAR is a library for generating visualization and data faithful infographics. LiDAR is a grammar agnostic which will work with any programming language and visualization libraries. Example, okay, and works with multi large language model providers like OpenAI, Palm, Hugging Face. The details on the components of LiDAR described in the paper in the tutorial, which I'm going to show also. LiDAR automatic generation of visualization and infographics using LM. LiDAR is a library for generating data visualizations and data faithful infographics. LiDAR is a pip install LiDAR. If you intend to use LiDAR with local Hugging Face model, you would need to install transformer library pip install. The LiDAR Python API. LiDAR offers a manager class that exposes core functionality of the LiDAR system. This tutorial will show you how to use the manager class to create visualization based on a dataset. Just one second.
When he was visiting
LiDAR offers a manager class that exposes core functionality of the LiDAR system to create visualization based on dataset. Multiple LM backends. LiDAR supports multiple LM backends such as OpenAI, Core, Palm, Hugging Face. You can switch between backends by setting the text generator parameter in the manager class. By default, LiDAR uses OpenAI backend. For the list of supported models and how to configure them, see the implementation. An API for chat fine-tuned language model. A simple Python package that provides a unified interface to several LLM providers of chat finding models. Okay. There is nothing particularly special about this library, but some of the requirements I needed when I started building this unified model interface. A single interface to create LM text generator which supports multiple LM providers. Standardized on an OpenAI chat ML message format is designed for chat finding models. For example, the standard prompt sent model. Um, for example, the standard prompt sent model is formatted as an array object where each object has a role and content. A single request is a list of only one message. A conversation is a list of messages, etc. Example, write a code of update x axis. Okay, so basically, unified message interface standardizes on the OpenAI ChatML message format is designed for chat fine-tune model. For example, the standard prompt sent a model is formatted as an object, as an array of objects where each object has a role and content. A single request is a list of only one message. A conversation is a list of messages. Uh, write write code of x. Update the axis. A single request is a list of only one message. A conversation is a list of messages. Being able to use caching for the responses. What is this? This is what I wanted. Interesting. While LLMX can use a Hugging Face transformer library to run interface with local models, you might get more mileage from using a well-optimized server endpoint like VVLM or FastChat. The general idea is that those tools let you provide an OpenAI compatible endpoint but also implement optimization such as dynamic patching, quantization to improve throughput. The general steps are install VLLM, set up endpoint, use OpenAI as a provider to access endpoint. LLMX makes some assumption around how prompts are constructed, how the chat message interface is assembled into a prompt for each model type. If your application or use case requires more control over the prompt, you may want to use a different library. For hosted models, this library provides an excellent unified interface as the hosted API already takes care of interface optimization. However, if you are looking for a library that is optimized for inference with local models, I recommend looking at VLM and TGI, a high throughput and memory efficient interface and serving engine for LM.
How does Docker help with production quality applications? And how do you build your own Docker file from
Running and serving LLMs is not an easy task. That's exactly where new library called VLLM comes and helps you massively. It is so easy to set up and it is really fast. And it is really fast because of a new unique algorithm called page attention. So in this video, we're going to see how to set up your VLLM, that is for LLM inference and serving. It's basically like an LLM inference engine. I'm going to show you the entire demo in Google Colab, and I'm also going to show you how you can hit the endpoint, like just to show that this entire thing works. I've picked up a very simple and easy model in this case, which is a Bloom's model from Hugging Face. And the reason I did it is because I'm fitting entire thing in Google Colab. So I've got like limited GPU. So that's one reason you could see like my GPU fluctuating a lot. But if you're doing it on an actual server, or if you're doing it for your professional enterprise reason, then you could basically load any model depending upon the memory that you have got. Before we move forward, I would like to give you a very important note here, which is this model is an Apache 2.0 license. Unlike Hugging Face TGI, which was recently in some kind of controversy because they changed the license, this is completely an open source license, permissive license, and you can use it. And before we actually see the hands-on code, let's look at the inference time. You can see when you use VLLM, the throughput is massively more. Like for example, if you normally use Hugging Face, you get like 6 requests per minute. If you use TGI, you get like 61 requests per minute. But when you use VLLM, you can make 154 requests per minute. And you can see these things for different kinds of machines, and all the machines for all the GPUs and servers you have got. VLLM has got like almost like 8 to 15%, 15 times higher throughput than Hugging Face, the typical inference that you get. And that is possible because of a new technology that they've called paged attention. Paged attention takes the concept from computer science, which is traditionally how computers are built, to use a paged memory to manage your random access memory, the RAM memory. This is like being there for a very, very long time. So what paged attention is trying to do here is paged attention is trying to take that concept, the paged memory concept, and then implement it for KV cache, which is a very integral part for any attention-based models. KV here is the key value that is being stored for LLMs, like especially the auto-regressive decoders, like the models that we use, the text generation models. So it is trying to use that concept and then do the memory management in such a way that we can use the remaining memory efficiently, and that is why you're getting the speed upgrade here. If you're interested in seeing a separate video about paged attention, I can do it with separate example, but just in simple language, they've got better memory management system. That's what a VLLM is doing. So now getting into the implementing or making VLLM work is very, very simple. All you need to do is pip install VLLM. So I'm also running this on Colab on T4 machine, like a GPU. See, typically you are not going to do this on Colab. I want to like get this straight. A lot of people seem to hate VLLM hate Colab these days for various reasons. I respect the opinion, but I make tutorials on Colab because it's easier for me to share the files with somebody. You don't have to necessarily do this on Colab. I'm making this tutorial provided. So first step. After that, you can either use this within Python. There are different ways to use it. You can say from VLLM import LLM, and then you can give this set of prompts that you want to use, and you can load the model. You can have an LLM class and you can load the model and then create an LLM object. So what are the models that you can load at this point? These are the models that you can load at this point. So it supports Baishuan, Bloom, Falcon, GPT-2, GPT Big Code.
Okay, this was 9 months ago. Let's check what are the models is accepted now. Third VLLM meetup. Crazy. Vibes. Project update. Yesterday. It was yesterday. June. Okay. Models. So, okay, we don't know which models are there. That can be that which models we can use. Okay, no worries. Anyway, interesting. Treats visualization as a code and provides clean API for generating, executing, editing, explaining, evaluating, and repairing visual codes. Data summarization, goal generation, visualization editing, explanation. Cool, let's try it out then. Okay. What is the so I just go D. D drive. I'm at my D drive right now, and I want to uh, um, um, okay, it's not this. I don't. Oh damn. Okay, I'm getting a huge doubt right now with the fact that I have downloaded Olama and used models, and then from there I have actually used Open Web UI. That is an interface which connects with Olama models, right? So Olama takes the port 11474 and this takes the port 8080. Cool. Now my doubt is that my doubt is that um, now this is a particular framework called LiDAR. if I download this slider and I want to use a model, how would I do it? Because the model that I have, I don't have it. Olama has it, right? And how can I patch these two together? Because I don't even know that is running in Linux, right? This is in Windows. This is a huge problem now, isn't it? Yes. I mean, with Olama, I don't think you can do much customization. That's a challenge right now. Okay, so I think I need to go back from the beginning and see how we can use LLM. But before we do that, why don't we just test this out first and see what is the what its capability, right? First, let's do that. So I'm gonna explore this one. So LiDAR as a library for generating data positions. I need a way for the infographics, LiDAR exam agnostic. Okay. Treats visualizations as a code and provides clean API for generating, executing, editing, streaming, validating, repairing visualization code from LiDAR import manager LiDAR manager pip install LiDAR. So setup is and verify your Python environment is higher. Preferably use Conda. Install libraries via pip. Okay, so I'm gonna do the same. So I'm gonna go Anaconda, PowerShell. I have that with me. So Conda env list. And let's delete a couple of environments which are not useful. So automation, ChatGPT, lead generation, Lila, OpenAI Shares. Cool, let's go with automation. And activate automation. Perfect. So let's go to D drive. D. Perfect. Now go to this one. CD. Let's put install like that. So guys, I'm right now installing the modules that were asked here. So what are the next thing that I need to do? That depends on LLMS and OpenAI. So first we'll also check the Python version right now. That's something we should do. So still installing the okay, and then LiDAR depends on LLMX and OpenAI. If you had these libraries installed previously, consider updating them. Once you have let's check our OpenAI chat. Platform. API keys. So we have created API key. Great. I will now check my Python. Oh wow, Python 13.12. So I don't have to worry about this particular message. Set up and verify that your Python environment is or higher. Great. I have 3.12. So now what I'll do is I'll run this command. Exit. Okay, great. Awesome. So that is already once you are met, set up an API key. I think I need to pull this, right? Yeah, I think I need to pull this. Yep. Where would I write this? Once you come set up an API key, learn more about setting API. Okay. A simple Python package that provides a unified interface to several LLM providers of channel fine-tuned models. There is nothing particularly special about this library, but some of the requirements I needed when I started building this. Set your API keys for each service. I need to go to YAML file. See, so for that I need to go and obviously download this. 1 second. Perfect. So what I'll do is I'll just do the git clone. Yes, git clone. Yeah, so that's what I'm gonna do. So I'm gonna go to my I'm on my anaconda prompt, and I'm gonna go to cd later. Great. And now I'm gonna go git clone and this particular later. Yes, later, right? Yes. Copy this command and then paste it here. So LiDAR is getting installed. So let that run for a while and we will read other documentation. So we'll look at what are the some of the files that we have here. Docker.yml, compose.yml, OPA key we have to enter here. Tutorial is there. Data model.py. Looks like they've written code on JSON for some. Yeah, these are the important Python files. Cool, so this is done. So that is done. I'll just go to my Windows and try to explore it. So I'll just try to change this. Guys, in my window, I can only share Explorer. Okay, cool. So I hope you can see my screen. LiDAR. So this is what was there. So now what I have to do to run this is basically just again gonna go to this one. So okay. Okay, so I'll open a Python. I open a Jupyter notebook now. Let me open a Jupyter notebook. So that should be able to take all the commands, because I think if all the packages are installed and everything is installed, so I think that should not be a problem. So Jupyter notebook. So it's loading up. Cool. So I'm sure you'll be able to see a Jupyter notebook. So I'll open a Python 3 notebook. Perfect. So this is learning LiDAR. Okay. Perfect. So we do have a tutorial which I can go check out. I also open that one out. LiDAR. We have a tutorial version as notebooks. Tutorial. Let me copy this. I'm copying and pasting the tutorial in here so I can open it. Let me open this as well. LiDAR automatic generation. This we saw. Cool. So let me just take this and probably I was just checking which one is looks legible, more legible. This is okay. Fine, let's go with this. Okay, getting started, installation. If you intend to use LiDAR with local interface, you need to install the transform library. Pip install. Okay, what is this? Okay. I'm I've never seen a package in a parenthesis. I'm sure this is wrong. Anyway, um, exposes core functionality of the LiDAR system. This tutorial will show you how to use manager class to create visualization based on dataset. Multiple LM backends. LiDAR supports multiple LM backends such as OpenAI. You can switch between backends by setting the text generation parameter in the manager class. By default, LiDAR uses OpenAI backend. For a list of supported models and how to configure them, use I know, but I didn't understand it very well. So it says that a simple Python package that provides a unified interface to several LLM providers of chat fine-tuned models. There is nothing particularly special about this library, but some of the requirements I needed when I started building this one. So provider OpenAI, supports Azure OpenAI models too, Google Palm. Okay, use unified messaging interface, Google tools, installation, install in development mode. Note that you may use. Note that you may. Note that you may want to use the latest version of it installed. Okay, set the API keys first. Export open key. You can also set the default provider and list of support providers via config file. You can also set the default providers and list of config file. Use a viable format sample. Yeah, guys, I have a rooster at home. Sorry about that. See the platform example. Texture config. But I don't want to know this. I want to know how can I use. Yeah, I don't want to know this. I just want to know how can I use this one. Cool. So what I'll do is I'll just do this for now. Okay. This is my first one. What? What did install? Downloading? Crazy, guys. Something it installed. Anyway, Let's move on. Let's do this. Cannot import LM from LiDAR. Why? Unknown location. Why is that? Import error. My package init setup Python. My model my Python is has single function. I am attempting to import as the following content. Okay, so LIDA LLM. So let me just go to the GitHub of LiDAR. What? Crazy. LiDAR, okay. LiDAR? There is no LLM here. The module my Python. The module my module.py has single function. I'm attempting to import. The setup file has the following content. For some support tools, import setup file packages. Setup my packages, package my packages. The import API. I'm installing the package with so right now I am learning from here, but do I need to move it? Could be, might be. If I move it, let me just close this. I have closed it. So let me move this here. Okay, where I have a. Let me try from here. Okay, CD LiDAR. Repeater. Bhai Saab. Okay, cool. So now I'm running this in a new interface. Let me try this. Oh, it ran. Oh, crazy. It ran, guys. Perfect. Thank you, Stack Overflow. So now I have to install this one. Don't restart. Let's close this, guys. Leave. And so what is the installation procedure? Install in development mode. So I need to install this here. I don't know. So where should I install this? Okay, first thing is I will upgrade my pip. I'm opening another Jupyter Notebook terminal here. Jupyter Notebook terminal, and I'm gonna activate. What? Come on, no. Sorry, I should have done Anaconda. Anaconda. Okay, and I'm gonna cd d perfect conda activate uh, uh, perfect. So now I'll put cd. What? So I'm gonna do this thing. First I'll upgrade the pip. Okay. So I've upgraded the pip. Python not found. Run without arguments install. Python was not found. What are you saying, man? Set Python 3. When I do this, my Microsoft store is opening. What? I just remove from this code. I remove 3. Yeah, so now it's working. Okay, successfully installed web. Successfully installed 24. Got it. So I've installed that recent version. Now I will do this. Okay, so let me just show you what's happening in the backend. So this is what I'm doing. Right. So now I need to I think I need to do this. Git clone. Then I need to use this one. So let's do that. Okay, I'll just go check my. Yeah, I have a folder called LLMX, and then it says something which I don't understand. It says to do CDLM and then P. What, man? Is it CD LLMX and then do pip install .e. I have no idea what that means. Obtaining file. Oh wow, obtaining file. Installing the dependencies, build dependencies. Checking if the build backend support build is editable. Okay, done. Getting requirements from. Okay, preparing. Successfully build LLMX. Install collected packages LLMX. Found existing installation. Uninstalling that. successful array. I have no idea what happened just now, but anyway, that is what we were told to us, so we did it. So I'll just change my screen to here. Guys, can you see my screen? Array, you're not able to see my screen. Shit. Crazy. Shit. Nice. Yes. Yep. Awesome. So the next command that I had to do was in the tutorial was the issue that I had was this, right? No model elements found. Now if I run this, yes, great. So that error got fixed, but now I need to do this. So let's open our file and try to find where we have text unit config file. So we'll go open the Explorer. Now what I need to do is I need to open LMX and find text generator config. So just write this, and here I'll go check. There is no such thing as text generator config. Okay, interesting. Generators, text. Oh. Oh damn. Okay, we have a tutorial here also. Crazy, bro. Can I search your so let's search for the internet then. See what we find. The problem with these guys is that since these LiDAR functions are very new, right? Okay.
How do you get started in digital marketing? Grab this course on Udemy. You'll get introduced to email marketing, market research, SEO, social media marketing, just about everything you need to get started. You'll get the latest technique.
In this video, we are going to build an application that will, and we are going to release, they have built a system that will help you automate this entire data analysis process, and that too powered by large language models. So you can see data.
Great.
Hello everyone, welcome to AI Anytime channel. In this video, we are going to build an application that will help you generate automated visualizations. And we are going to use something called LIDA, which is a new release by Microsoft. They have built a system that will help you automate this entire data analysis process, and that too powered by large language models. So you can see LIDA as Pandas AI killer, I will say. That, to be honest, Pandas AI I think they were a little slow when it comes to working on the active issues or on their roadmaps. Now we have a new system that's called LIDA by Microsoft, and it really looks promising. If I talk about LIDA, the meaning of LIDA is like loved by the people. And I when I show you the demo, you will believe that this might get a lot of love from the community. Okay, and let me first show you a quick demo of that what we are going to build in this video, guys. So if you look at here, I have a Streamlit application, and that's what we are going to develop in this video. And I have two options. One is summarize, and the other is question-based graph. So the good thing about LIDA is that it also helps you query your granular data. You have CSVs right now and the Excels and the other on the roadmap. You can upload a CSV file and you can generate different graphs based on different queries or questions. So it can look at your queries and then can generate graph. How it does it, I will explain that in a very high level in a bit. Now, if you look at here, we have something called summarize and the other is question-based graph. So let's first look at summarize here. And in the summarize, I'm just going to browse the file name. And this is the data I've uploaded. Let me first show you what data. It is the same data file that I have used earlier to build a CSV chatbot using Llama 2. I'll give that video in the description as well. You can have a look. That video is completely open source. Doesn't work that good, but now we have a lot of workarounds with Pandas AI and CSV loaders, blah, 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 right? Now, this is my source data. And if I work as a data analyst or you are a data analyst and you want to augment your entire workflow using a large language model, this is the agenda in this video, guys. Now, you can look at here. This is a 2019 world's different countries and their happiness score. So you can find out the happiness score, which is based out of 10. Then we have GDP per capita. We have social support, healthy life expectancy, freedom to make life choices. And I hope North Korea is below in this, generosity and perceptions of corruption. Now, these are some variables, the metrics, and based on this final score has been calculated. And you can look at here, Finland, you scored the chart here. Finland, Denmark, Norway, the Nordic countries are doing really good when it comes to happiness score, at least according to the data. Now, this is my source data, and I want to generate some visualizations or infographics using LIDA, and that's what this tool is going to help. Now, once I upload it here, I can find out all the details about this dataset. That's what we do when we use Pandas, right? df.info, df.save, df.type, whatever, right? We do some basic analysis of our data frame when you use Pandas to analyze your data frames or CSVs or Excel. Now, if you look at here, there's some information. First, it talks about the file name, main column, which is overall rank. It gives you some sample that how does it look like, and it has number of unique value. It has country. You can look at some countries like Bulgaria, Mongolia, etc. Number of unique values. 156 countries are there in that CSV that I was showing you. Then we have score. We're talking about their score, and we used to do here for that. It also gives you questions, and I will cover what goal mean, by the way, in a bit. It has different. It has 4 major features: goal, summarize, visualize, and there's one more that will cover with their GDP data for the first 3. It will give indication. Now we have built this app, right? You can just how will the visualization look like? It says it's scatter plot of score versus GDP per capita. That's the heading of your graph. It's one goal. We have 2 goals. And then we also have the chart here, the chart which I only get it for the first row, where we did chart and the first index of the list. That's what we're looking at, the first element of the list. We'll see that in the code when we're writing the code. Now, if you look at the goal 1, we have a detailed information about how we're going to execute that goal and get our chart off. It gives you a detailed information that this visualization will help us understand the relationship between a country's GDP per capita and score. Not only you just go and randomly country or region of capita, we file or chart. That's for our goals graph. Now, when you look at question-based graph or the query browse, because it was model. Once you upload our data, like a CSV file, and then the app starts running. And here, for this particular query, I get the response from a visualization execution. There's an executor that works in the backend. And I have kept it verbose because I want to explain you that it first gives you a base64 string over here. It's a base64 code, by the way. Now, if you want to use this code or run inside a backend process as well, you can also do that. And here we got our image for this particular query that we have asked. Now, imagine how easy it makes analytics that Microsoft has released. Example, here you can pass an instruction in backend that, okay, give me graph of red color. It will set the color labels for you. So this kind of customization, you can different kind of research paper over here. You can read the paper in French. You'll have question that, hey, Llama 2 is not performing well for CSV data. And when we're building a chatbot, it will not do it, to be honest. It's still not there. Okay. So because even if it's an instruction-driven model, they are not that capable of performing really good. There will be wrong, false positive, there will be hallucinations, some gibberish outputs. At least GPT 3.5 or other closed source model performs a bit on expectations that we have when it comes to granular data. Now, this kind of frameworks, library or systems, whatever you call it, they're calling it a system here. The LIDA is a system. That's what they're saying. Now, this is really going to power that LLM workflow when it comes to performing well on CSV or Excels. So this is why it's important. It understands the semantics of data, enumerate relevant visualization goals. First, create the goal and then generate. It's not directly generating it. It's a multi-step generation process. 4 things that they features on their modules. One is the summarizer that converts the data into a rich contextual meaning, okay, of your CSV file. That's what it does for the first module in a very natural language summary that an LLM can understand. Directly feeding an LLM a hell number of your numbers in your data frame. It's not going to whole explorer. It only is. You can find it has find about. Okay, if you look at these 4 things, summarizer, which is rule plus LLM combined, And then the other is LLM, only goal explorer. Once you give a natural language to an LLM, it will create some goals for you based on that natural language information that's available to LLM. And then it generates the graph and the infographics. They're the 4 modules. And Lida, one of my subscriber today just mentioned, right, when I'm creating this video, just 30 minutes before, I wanted to create a video on Lida, and somebody, I think if you are watching it, I forgot your name by the way. Somebody had just suggested me to create a video on Lida, and that's why I also want to thank him as well. Thanks for suggesting me to create a video on this. Now let me just close this. Let me just close this as well. Now let's start developing this application, guys, and we'll explain a bit at how you can do it. And not only with closed source model, how you can also use models from Hugging Face. And I know that some of you might be interested into using a local model. So let's now start developing this application, guys. So to develop this application, guys, you can see I have a folder here that's called Lida.demo, and I will open this in VS Code. Let me just open this in code dot, and then it will open VS Code for me here. You can find it out. Let me just open it. Now here you'll see I have a requirements.txt. Now in requirements.txt, I have few libraries and packages. So Lida, that is compatible with 4 different types of model provider, I will say. So you can use OpenAI models. And again, Azure OpenAI is command there as well. Then you can use Cohere model. If you have Cohere model, you can also use Cohere model. Then you can also use Palm model, like for example, Vertex AI models. You can use Text, Bison, etc. And then you can use H model right now. So if you want to use GGUF or GPTQ model right now, you cannot do it. You can only use the transformer based model, which are not quantized. Okay, the autocausal model you can use. Now here, if you look at, I have Streamlit, that's the dependency of the Streamlit application. I have Torch because I will show you, I'm not going to use HF model because that will probably take a bit of time. I will explain that how you can replace the OpenAI with an HF model there. It's just a single line of change that you have to make. And you might get an error that provider has an extra keyword or something if you are using LLMX, because it uses LLMX. I'll show you when I'm writing the code. Because I'm going to use OpenAI model here in this case. I'm using GPT 3.5 Turbo. So I'm just storing it in an env file. I'm just using it in a load.env. Let me create an app.py quickly here. Now here we're going to write the code. So let's do import Streamlit as st app manager text generation config and then the LLM. These are the required dependencies, the modules from Lida. Okay, so we need a manager that will manage your LLM, and then the text generation config where we'll have some configuration related to a large language model, and then LLM is something that basically, that will so LLM is something that where you pass the name of the LLM. Okay, so let's see that. Now here I'm going to also use from.env import load.env, and I also need import OS, I need import OpenAI, and I need import, let me just do import IO as well, because we want to use PIL below here to save the image. We're going to get a Seaborn type of image. Now from PIL import image, and from IO import bytes IO, because we want to handle the CSVs, the uploaded CSV. And we're going to need import base 64. Okay. Okay, fine. Now let's do a load.env here. So let me just do a load.env, and I'm just going to do OpenAI.API key, and I'm just going to get that from env file that we have using get env function, and this is the name that how I have defined in that env file. Now OpenAI API key. Now we are done with this, guys. Okay, so let's write a function, or I will not probably write a function. Let me just go to my GitHub.
I'll just stop recording and